The reason that we want to weight scores that are farther from the mean more heavily is that we're assuming that the population follows a normal distribution. If the population follows a normal distribution, then you have lots of scores near the mean. And that means those scores are very likely to end up in our sample. But as we move farther and farther from the mean, what happens is scores become less and less frequent. And that means they're less likely to show up in our sample. So if we have some, then we want to weight them more heavily, because we're assuming there's probably other scores out there too, but the chance of all of those showing up in our sample is very low. So if I have a score that's 10 points away from the mean, well, there's probably a score that's 9 points away from the mean, and there's probably a score that's 11 points away from the mean in the population. But the odds of getting all of those in my sample is very unlikely. So instead, I'm going to weight that 10 more heavily to try to make up for some of the missing data that's going to not show up in my sample, but that I think exists in the population. And this is part of why the variance is giving us an estimate for the population.